Hello everyone. Welcome back to Code and Silicon, your journey from transistors to Python. In part 1 we explored the physical machine, the CPU, RAM, and all the hardware. But how does that hardware understand our software? How does a line of code become an action? That's what we're diving into in part 2. The bridge, how hardware meets software. This 3-part section is all about the critical, invisible layer that translates our human-readable instructions into actions the hardware can perform. Let's see what's coming up. In session 5 we get down to the absolute basics. We'll meet the only language your CPU truly understands, machine code. This is it. A stream of ones and zeros, where each sequence is a direct command for the CPU. Move this number, add these two values, jump to this memory address. It's powerful but incredibly difficult for humans to work with. So, to make it a bit easier, we created a language one small step closer to our own, assembly language. Here, simple, memorable commands like load, add, and jump correspond directly to those binary instructions. It's the CPU's native language, just with nicknames. We'll look at what these commands do and how they control the CPU at the most fundamental level. But let's be honest, most of us don't program in assembly. We use languages like Python, C++, or JavaScript. These are high-level languages, they're designed for us, with syntax that looks almost like English. So, how does 5 plus 3 in Python become the machine code that the CPU needs? Enter the translator. This is the job of a compiler or an interpreter. It's a specialized program that takes your entire high-level code and translates it down into that machine code or assembly we saw in session 5. But there's another crucial manager in this process. The operating system, like Windows, macOS, or Linux. The OS is the ultimate boss. It doesn't just run your program, it manages the hardware. It decides what gets loaded into RAM, which task the CPU works on next, and how your program saves a file to the disk. It's the essential platform that makes everything else possible. Now in session 7 we're going to put it all together. This is the big payoff where we connect parts 1 and 2. We'll take a single simple line of code, x equals 5 plus 3, and we will trace its entire journey. We'll follow it from the code you write all the way down to the transistors flipping inside the CPU. It's a fascinating journey that demystifies what actually happens when you hit run. So, if you've ever been curious about what lies between your code and the silicon, this section is for you. We're building the bridge between the abstract world of software and the physical world of hardware. In the comments below, let me know what high-level programming language you're familiar with, or if the concept of machine code and assembly is completely new to you. Thanks for watching. See you in the next session.